Simple at Complex presents Why Aren't All Penguins Criminals? Hello, we're Simple at Complex.
We're a group of PhD students from University College London. This means that we have already spent a number of years at university, and rather than going to lessons and taking exams, we do our own research into questions we're interested in. The questions we all research are all very different, but we all have one thing in common.
We love maths and we love biology. In fact, we love them both so much that we use maths to study biology.
We do this using something called modelling. In this workshop, we are going to show you what modelling is, how it can be used to answer questions about nature, and give you the chance to try it out yourself. Now, when I said the word modelling, you probably thought of fashion models, like we see in magazines and on the television. But when we are thinking about a model, what we mean is a simplified version of a real-life situation that can be used to teach us important things about the real world. An everyday example of how models can be used is the weather forecast that we see on the television. Scientists use models of the weather to predict what the weather will be like over the next few days. Like all models, these models have to make simplifications, which is part of the reason why they don't always get the forecast completely right. But in fact, you may have used models yourself before. In many ways, a board game is a model. You have a series of rules that describe a simplified situation. For example, Monopoly could be described as a model of buying and selling property in a city. Just like other models, Monopoly makes simplifications. For example, in Monopoly we use dice to decide how far each player moves in each turn, when in real life, how people move around a city is much more complicated than this. Even so, by looking at who finishes the game with the most money, we're able to make some predictions about what the best strategy would be if you were buying and selling property in real life. When we're building a model, it's important for us to decide what questions we want to answer, what the purpose for the model is, and what we want the model to do. We need to think about what type of model we should build to try and answer our questions. Remember, models are simplified versions of real life. So we need to think about what simplifications that we can make so the models are easier to use. When we make these simplifications, we need to think about what assumptions we are making and how they will affect what we can learn from the model. Today, when we make a model, we're going to fill in this table to make sure we have thought about these important things. Another example of a model is a model aeroplane, like the ones used to test the flow of air in a wind tunnel. Let's go through the table as before, this time imagining we're creating a model aeroplane. So, here the question we're asking is, can we improve the way airplanes fly through the air? We're answering this question by building a physical model of a real plane. A model aeroplane for this purpose does not need all the details of a real plane, so we might make some simplifications. We might make our model smaller than a real plane, so it's cheaper and fits in a wind tunnel. We also could leave out some of the complicated parts on the inside, like the motor. Instead, we want to focus on the features that are most important to how the plane will move through the air, like for example, the shape of the wings. We're assuming that a small model of a plane will fly the same as a full-size plane. We're also assuming that leaving out the complicated parts that are on the inside will not affect how it moves through the air. What we are left with is a simple version of a real plane, but one that can still teach us important things. Now remember, models don't have to be physical objects like a model aeroplane. Another type of model is a mathematical model. A mathematical model uses maths to describe and predict something. But how can we use maths to answer questions about nature? Make sure you listen carefully, because after I tell you about this example, you're going to fill in the table by yourselves. So, let's imagine you're a scientist and you're interested in a rare and endangered type of monkey. Because this type of monkey is endangered, it is important that we have a good idea of how many are alive in the wild. But because these monkeys live in a big rainforest and are very shy, it'd be impossible to count them all. How might we find out how many there are? We can make a simplification and instead do a small experiment where we cover part of the rainforest with cameras and count how many monkeys we see. We could then multiply up this number to get an estimate of how many there are in the entire rainforest. Now it's your turn to have a go at filling in the table for this model on your own.